Okay, now we continue for next example, a few more example, and then we finish this handout. Okay. You take your handout up and go to the page 740 on the example 16. Example number 16. Okay. Everyone have the handout now? Okay, now you read the question request, what we have to do. A university professor determines that 80% of this year history candidates should pass the final examination. The examination results are expected to be normally distributed with mean, okay, mean 62 and the standard deviation 13. Sorry. Find the lowest score necessary to pass the examinations. So question give us the 80% of this year history candidates should be passed the final exam. So 80% is the probability, the area under curve, if you see from the table. But we don't have this one, right? So that means equal to the probability is what, 0.8. Then we have to find out this value, the probability, and from the table. But we couldn't find exact this number 0.8, so you can find between, okay, between the value of 0.80. So you're gonna do the same way. Now we draft it for what the information question give to us. So we have this area probability under curve. Then the question give us mean, right? Equal some we represent with x bar or the mu psi equal to 62, right? At the same time, standard deviation or SD equal to 13. And then question want us to find the lowest score, okay? Necessary to pass the examination. Examination. Okay, now we start. Okay, so we have all the data about the question request. First of all, we have to so in this case, we need to find k, right? So in this case, we can write down now the solution. P x greater than k equal to 0.8, right? 0.8, that means 80% here, 0.8, 0. Or you can do either way, or P probability of x greater than k, which is should be less than, sorry. Because we have if greater than x greater than k, the probability equal to 0.8 or 80%. Then if less than, right? If less than this one 0.8 or 80%, so less than should be the less one, right? Become 20% or 0.2. So we can find out the value of k by using greater than this one, the first case, or the second case less than. So x is k right now. K is what? Is the passing mark, right? Passing mark, or another word is like a C score, the C value, the passing mark. Okay, so now we can do either k greater than or less than, but I will explain by less than first, because less than is much easier to do. Because when you read the value f of X or Z or C score, right? When less than, when you get the, remember, when we read the value of probability under curve from the table, we leave from the normal, like this one, right? From the graph here, the normal distribution, the normal curve here. We leave from the left end area, right? Left end area up to the point, whatever you want. So if one we lead, that's the exact, the answer, the valuable, the answer we need. So if we leave from the less than cases, okay. So if you leave from greater than, you have to do subtract 1 minus something the area. So we work on the less than first, the easier, and then we work for the greater than later. Okay, so we start here. Okay, so then we work from the less than here. Okay, so for this one, like a P, when we have P, probability of X less than or equal to K, which is equal to the probability area under curve is 0.2. Okay, then we use the formula we have, right? Formula of C score equal to X minus mu or X bar, right? Equal to SD. Okay, so from this one, you do at the same time left side and right hand side. So we're gonna, from this one, from this formula, we're gonna have P X, right? Minus mu. Mu is a X bar. We have already mean 62 here. 62. So 62 less than K, right? And K minus mu at the same time. Do the same action, left and right hand side. Okay. And this one divided by SD, right, formula, and this one divide SD also. So SD, this one is what? 13, okay, equal to 13, question will give to us. And this one equal to 0.2. So then this the whole thing, X minus 62, 62 mean X bar or mu over SD, mean the value of Z, C score, right? So we have, remember we have to convert X, if we know valuable X, then now this is a word problem, X, right, is like a part of C score. You have to convert X to the pattern of C score first, convert X to the C score. Right now we have this one that set C score. So we have C score is this one less than equal to K minus 62 over 13. This is equal to 0.2. Now from this one, we go back to the table 7, what the page number? 7, let me see. 75, okay, the page 75, go back to the table to looking for the area of 0.2. 75, the table, okay. Looking for the area 0.2, but 0.2 we couldn't get exactly, right? Then you find the between. So you go to lead the, they should be allowed 0.84 and 85, I think. So you go to the right hand side of the table, the positive one, set greater than 0 there. You lead from, for example, we come, I draw the table here, right? If I draw the table here, you see it have table here, right? And this one, Z, and you, this one is a 0.0. You lead down to 0.8, lead until 0.8 here. And then you see the 0.8, the area allow 0.2. Oh no, this one, sorry, it should be 0. Should be negative side, sorry. So this side, let me erase. This one should be negative because we were on the less than, we were on the 20% first. 0.4. Go to the left hand side. is a start from negative 3.4, right? You lead down, search for the area. Right now you have to search the answer inside the area here, okay? So the area 0.2, 0.2, very close to negative 0.8. You lead down to 0.8, 0.8 h 0.84, right? So this one is 0.00, and then you lead it up to somewhere here is a 0.4, 0.04. Okay. This one 0.04. So from here, when you lead up to here, you will make negative 0.84 become equal to 0.2, 0.2005. Okay, and then you go on to 0.05, and then this one you lead down from the 0.8 that you made at this point. Gonna be what number? You see from the table, this one gonna be equal to 0.1977. 0.1977. So we have now, okay, that means this one equal to the C-score is negative 0.84, and this one negative 0.85. Okay, so you use the ratio formula we do from like a previous example, okay, to get the value of K. Then from this one, or you can draw like a one table like this, one line on linear line. When you like the ratios. Okay, because 0.2 is assumed allowed here, right? 0.2 here. And this number is from the left-hand side here, right? It's a 0.1977. And this size is 0.2005. Should be from the left. Okay. This one 0.2005. 0.2005, and this one is a 1.9 no 0.1977, 0.1977, and we let this one as a assume this one as a. Okay, so this is a. And then you can get, and this one equal to the C-score is what 199. 199 is a negative 0.85, and this one is negative 0.84. Okay, so then you can use the ratio now, right? Can get this one A A minus this one, A minus this one over this one minus this one. So the first one we have A minus and minus 0.85 over negative, right? Negative 0.84. So minus 0.85. These are ratios. Okay. Equal to this side A equal to 0.2. Minus this the C-score, which is equal to probability is what? 0.1977 divided by, now 0.84 is this one, right? The probability area is 0.2005 minus 0.1977. So then you simplify this one, okay? Simplify both sides and then you do cross multiplication, get the value of A. Okay, so this one check, I think it's correct, yes. Okay, so now you solve, simplify this one, find the value of A. We have approximate negative 0.84178, I think. Okay, when you get A, this one, right, you replace A in here. Okay, replace A in the position of 0.2. So the next step after this one, you're gonna get the value of K. So K minus 62 over 13 equal to negative 0.84178, right? Okay, equal to this one, 84178. And then you solve for K. So K come out approximate is what? 51.059. Okay, so this is the answer now. So this is a minimum pass mark or minimum passing mark, which is equal to 51.059. This is a passing mark, passing, you can say passing the exam, the low. So this is a minimum. So this is a minimum. Passing mark. Is it equal to 51 approximate? 51.059. That's the final answer. Okay. So now this one, because we work for this one when the case of probability less than K, right? So this one you get the exactly answer. Because this one you leave from less than, so if you plot graph, let's see, plot graph. If you plot graph, right? You have to plot graph actually. Right? You have the normal curve. And both sides have to be arrow because they go infinite value, infinite term. Okay. So the mu, the question we have mu here, this one, for example, assume mu is here, 62. So you find out the K already. This one is we get the answer is K is a 51.09 because you leave from the less, right? So this one is a 51. is a value of K, 51.059. This point is a K. And when we work from the area 0.2 here, right? 0.2 here, we leave from the area from the left end. You shade that area up to here. Shade the area here. Okay. So this area is a 0.2. Okay, that's a graph you have to plot. Okay. Now we go to work if we work in the case of if greater than, if you want to find this one. If work on this case, if you want to work on the x greater than k, which is equal to 0.8. Okay, we go next page to work on this case. So this one is work according to less than px less than k equal to 0.2. Okay, so we go next page. If we work on the if p of x greater than k, which is equal to the area of 0.8 or 80%. Okay, so this one, when work, we do the same way. You have to find the area. If you lead from this one, find the area really close to 0.8 between, just say find between the area between 0.8, because we cannot find exact value 0.8 from the table. So you have to find the area between this one 0.8. So you go to the table again, the page 735, right? Go to the page from the table 735. Read the table, read the value of 0.8. So if I draw the Z-score table, I draw this one. So this is C. So 0.8 or 0.80, where they are. You can go to the table 735. This one should be the positive side. From the right hand side table, right? It's a 0.0. You keep reading up to 0.8, right? 0.8, and see the area between they have is what? 0.4, right? This one 0.0, right? 0.00, or this one 0.01. And next you lead up to 0.04, or 0.04, right? From this one you lead down, then they made the 0.8, you will get the answer. You get the value between. Is 0.4 is 0.4, 0.84. Is 0.7995, right? We have 0.7995. And go on, lead up to 0.5, right? 0.5 here. When you go down, you make the 0.5, 0.85 gonna be 0.802. Okay, so we get the between now. 0.8 between these two numbers. Okay, that means this one Z-score equal to 0.84. Okay, and this one, the Z-score equal to 0.85. Now you like the ratios. Okay. From this one, okay. So you leave this one gonna be the ratio again. So if A, right? So you like this one, the higher minus lower first. Okay, if you have 0, this one, the between, right? Like 0.8 0.023 minus 0.7995. Okay, this one will equal to 0.85 minus 0.84. Okay, and this is a denominator, so you write the numerator. Okay, so this one A, let this one as equal to A. Let this one equal to A. Okay, just say the ratio, not exact. So A, and then A minus this one 0.84. So this side A is a 0.8. Okay, minus 0.84 is 0.7995. Okay, if you don't know how to write this, you draw the number line like I did from the last example, same thing, okay? So from this one, sorry, you just simplify and do the cross multiplication to get the value of A, okay? So you simplify it, okay, use calculator. So we get A approximate 0.8418. Okay, that's the value of A. Once you get A, do the same way, go back to replace this one. Okay, so from this one, we're gonna have do the same way where this one, when we have this one, if you have from this one, you have to convert X to Z first, right? You convert X to C score first. So if you do this one, so X minus mu, right, over SD, gonna greater than K and K minus mu over SD. And then you replace, correct? X minus mu is what? From this question, mu is a 62, SD is 13, right? Greater than K minus 62 over 13. This one equal to 0.8. Okay, so because this one, the whole thing's a C already, is that score. So you can write as a C because we want to convert X, right? X to Z here. So we have greater than this one. K minus 62 over 13 equal to 0.8. Now, because then we got the value of A already from the table, right? This one, we have A here. We have value of A here. So you replace A in here. Okay. So gonna be, next step gonna be K minus 62 over 13 equal to next 0.8418. Okay, 0.8418. Then you simplify and then just do cross multiplication, get the value of K. So this K equal to 72.943. Okay, you use a calculate because it's a timing, so I don't want to calculate here. So you do it. The value of K equal to 72.943. But then you observe from the last one, we get the, let's see, the final answer from, if we work from the P, right, go back to this one. From the last one, we get P X less than K equal to 0.2, that one, remember, 20%. So we get the value of K, we get the final answer is what? 51 point something, remember? 51.09 something, if I recall. 51.059, right? So the answer is supposed to be, the answer should be equal to this K. But this case we leave because of greater than, right? So we have to do some more steps. So maybe I can draw a normal curve, the graph that explain. So this one, right? Okay. And this the mu or mean, right? At this point, 62. Because we work on the greater than, so the area we got it should be lead from the left end, lead to the left end, right? So we got K here. So K 72, 72, I like pink color. Should be somewhere here, correct? Just say here, 72 approximate 0.943. So 72.943, the is equal to the property area, the value is under curve equal to 0.8. That means from the left end, we lead the area. We always lead the area from the left end, correct? So this one, just say from here up to this one, the pink color here. This one equal to 0.8 because we lead from the left end, right, to this K. This is a K value here. It's a K, okay? So, and 62 is a mu, I mean. 62 is the X bar or mean, mu, okay? But question need how to find the lowest score, right? They want to know the lowest score for the passing grade, what the lowest score gonna be. So then we have to do more steps from this, because if you subtract the distance, right, the area or distance, the length from here, 62 to 72.943. If you subtract this one, okay, I use another color. If we subtract this one, okay, you minus subtract, it's gonna be 10.94, right? 72 minus 72.943 here. I like it clearly, the color. 72.943 here. And when you subtract 72.943, subtract 62 is a distance from here, right? From here to here. So equal to approximate 10 point, subtract it, 10.94. Okay. But because this K we got right now here, 72 is a higher K, which is question one, the lower. So we have to do some subtraction. When we know the distance from here, because this is a normal curve, from this point and reflect, right? Reflection, symmetry to this side, this one, this length here should be equal to this side also. Okay. We want to find the lower mark, okay, the lowest mark. So this point, the distance this from 62 to 72, that's equal to 10.94, should be equal to this side also, right? So from this side, from this 10, and this one gonna be 10.94 also, from mu to this point. So then you can use the 60, apply the 62 minus 10. So you get 62 minus 10.94. This one, this point gonna be equal to, I use the blue color here. So this point gonna equal to what? 51, approximately really close to 51.0592. Okay, 51.59. Okay, this point gonna be 51.059 because this 10 is equal from here to here is a 10.94. So you get this one, this is the answer. So that means from when we draw this line up here, okay, so that's the answer. Actually, this area here, the empty one here, this side, should be symmetry to this side, right? So that means this side is what? 0.2. This area gonna be 0.2. Okay. So this the answer. That's why when we work from the greater than, we have to do more steps. Get to more step to get the final answer. So if we do the less than, right, like a beginning, we do that one less than. In this case, we will get the answer right away, because when we read the value from the table here, we always read from the left hand side less than. So this one we get the answer right away, which is going to be more easier than we do the greater than. Okay, so this question, you have two choices, work according greater than this one, but you have to do more steps to get the lowest, because the according question need the lowest point. Everyone get? Okay. But if you work less than, we get the answer right away directly, because we lead according the table, and the table we lead for the less than from the left end area to the point. Okay, so this is an example for example 16 on the page 740. Okay, take a look and see. If you have any question, you can ask me in the class also if you want. Right? So we go another one more example, the next example on, wait, we could go next page. The example 17. Example 17. Example 17 on the page, page 741. Go the next page, okay? Page 741. See the question, okay? They say find the mean and the standard deviation of normal distribution random variable x if, okay, if p x greater than 50, which is equal to the probability area or probability value is 0.2, and p sorry, x less than or equal to 20, is equal to probability is what? 0.3. In this example, you can observe, okay, right now they give you the K, value of K or the C score, right, this one. And then they turn out become, they want you find mean. They want to find mean and SD, standard deviation, equal to what the value, what the answer. Before they will keep you mean, keep the data of mean and standard deviation and so for C score of the probability. But now they give you just convert, right? Become, they want you find mean and SD, just opposite. So in this case, we still do the same way anyway, okay? So work from here, because this is the X value, okay? So we have to convert X to C score first. But in this case, you observe the first one here, right? X here, greater than 50, greater than, you see that, greater than here side. So we better work on the less than better. Will match to this property, this side, okay? So in this case, we can, this one we can imply that what? Become P X less than, right? Less than 50. Then equal to 0.2 is greater than, then less than gonna be what? 80%, which is equal to probability is what? 0.8. Okay, now we work from this one and this one to get the value of mean and SD. standard deviation. Okay, so now we work from this side first if you want, right? Or this side, doesn't matter. Okay, so from this one, we work from the x less than 50 equal to 80% or 0.8. Convert x, do the same way, convert x to z to c score. So p of x minus mu, right, over sd less than this size of 50, right? Minus mu this side, mu unknown, correct? We don't know, mu unknown, over sd unknown also. And this one equal to 0.8. Okay, then after this one, you're gonna have p, this one, the whole thing's a c score or set, right? Less than 50 minus mu over sd equal to 0.8. Okay, now do the same way. You have to go back to the table on page 735, looking the area, the close or between to 0.8. Do the same way, exact. Okay, so you go to read, because the time, okay, I think hope everyone know how to read table already. So we're gonna have 0 point, the area between this one, you can go to read the C score is between 0.84 and 0.85. When you read that one, right, 0.8 from the table, they're gonna be, let's see, which way, analyze space. When you list this one, you're gonna have 0.84. You go to the C score, okay, 0.84. This one equal to 0.84. I think we saw last same last sample. So equal to 0.7995, right? And 0.85. The probability, this is a C score, okay, this one C score. And this size the area under curve, the probability. So this one equal to 0.8023, if I recall. So when we have this one, you do the ratio, correct? Okay, this from the table, okay? And then from that, we can write it down, say, let this one 0.8 as a A, okay? Or this one like a or X. So we have A minus, we can do this one, like the ratios. So you can get the high, low, high minus low, right? So this one 0.8023 minus 0.7995. Okay, this is a ratio, right? And this side gonna be cannot be straight line. And this side gonna be what, 0.83. This one is a 0.85 minus 0.79. That's a 0.84. Okay, 0.84. Then the top here you use A, right? A is do the same way again, 0.8 minus this one, 0.84. And this side you can see 0.8 is a A, right? So you write A here. Minus 0.84 equal to 0.79. That means this one. So minus 0.7995. Then again you simplify and solve for value of A. Okay, 0.84 here. 0.8. This is 0. Let me check correct. Oh, this side A is 0.8, and this one 0.8.4. Or this one long. Sorry. 0.5 and 0.8 and 0. This side should be 0.8 along here. Should be this one A here and this one. Okay. A should be this side. It's a because have to start from A and lower the whole thing. And A, this one 0.8. I like so. And get enough. So you can draw the one line, right? If you want one line, do the when you like this one, you can draw like this one. Draw one line, right? And then you can see because we have 0.8 here, you between what? 0.84. This one, right? 0.84 and 0.85. So if say this one A, right, and then this one is 0.84, the C score is 0.7995, and this one 0.8023. Then you can use A, because 0 between this one. Okay, you can use A minus like this one. A, this one A should be below because this is a C score. And then this one 0.8. But 0.8 is between this number. So this one can minus this, right? So you can see the ratio of this one, A minus this one, over this one minus this one. That means this one. And the left-hand side here, you get this one minus this, the ratio, right? Go over this one minus this one. So the top one means this one. Okay, this is the ratios. Okay, then you get the value of A. A, we got A approximate. You use a calculator, right? What we have here. Approximate 0.8416. You use calculate, simplify, and do cross multiplication. Okay. Once you have this one, this side do the same way. Okay. Actually, they're all the same way, same step to doing. Then you do this one when the property x less than. Okay, use a blue color here. This one. Px less than 20, which is equal to 0.3. So do exactly same on this side. Okay. Can I skip and then you do it? And you can compare in your handout. Okay, just we need, now we work on this one. Px less than 20 equal to 0.3. Okay, so then this one again, you use convert x to c score first. Okay, this x. So we can write down x minus mu over sd less than equal to 20 minus mu. mu is the unknown, right? And over SD. And this one equal to 0.3. Or maybe you come back to this one first. When you get A, you replace there. Okay, when you get A, this side, the pink one here. When you get A, you get this one replace this A, value of A replace in here. Because we let A equal to this one. Okay, from this one, the next line you can have is 50 minus mu over SD equal to 0.8416. And then you count this one as the equation one. Okay, or simplify. You have 50 minus mu equal to 0.8416. Okay, times standard deviation. So you can have this one become move this one become plus. So we have 0.8416 standard deviation plus mu equal to 50. And then you treat this as equation one. Okay. So, and then we come back to this one. The property when x less than 20 is equal to 0.3. Work the same way. And this is going to be equation 2. And then to solve for standard deviation and the mu. Okay, from this one, come back here. Continue this one. So we have P. This the whole thing, the C score already is that less than 20 minus mu over SD equal to 0.3. Then again, you go back to read the table for the property area under curve 0.3, drop in what the C score. But we can't find exactly 0.3. Again, you find the between. Okay, so by the between now, because the time I give you this one, 0.3 from the table is, because the C score is negative 0.52. You go to table, take a look, okay? This one equal to 0.5, negative 0.52 equal to 0.3015. And the between, right, 0.53 equal to 0.2981. Go to see the table. Okay, so when you have this one, you can see 0.3, the area property is dot between these two number, right? 0.3. Okay, so then do the same way like the ratios. Okay, 0.3 between these two numbers. So you can start from, again, let this one, right? Let this one or this one as a equal to A. Okay, so this side we can start from 0.3 first, right? You can write down 0.3 at the ratio minus 0.2981. You can draw the number line like this if you want, and then over 0.3015 minus 0.2981. Okay, because 0.2 is A, right? So A minus 0.2981 is what? Negative 0.53. So minus 0.53 over 0.315 is this one, right? It's a negative 0.52 minus negative 0.53. It's a ratio you can observe, right? 0.3 mean A minus 0.281 here is a negative 0.5 from here. And This one zero is a ratio 0.3, 0.3015 means here negative 0.2 and minus this one 0.298 means the negative 0.53. Okay, then you simplify, do cross multiplication. Okay, do cross multiplication to get the value of A. So A gonna be equal to approximate gonna be negative 0.5244. Then you do the same way, replace A in here. Replace the value of A in here. So we're gonna have 20 minus mu over SD equal to negative 0.5244. After this, you simplify, right? Simplify this one, same like equation one, simplify. So you're gonna have this one, you're gonna have negative 0.5244 times SD, right? Times SD side. And then plus mu, right? Just say cross multiplication this one and move mu negative equal to 20. Okay, so let this one become equation 2. Then you do equation 1 and equation 2 to solve for standard deviation and the mu by using substitution. Okay, by using this one between equation 1 and equation 2, solve for standard deviation or mu. You can use either way by substitution or elimination, or you can use a matrix by the use the common rule, right? Up to you. So then you're gonna get the answer because question requests us to find mean. That means SD. X bar, or sometimes we write as a mu sign, and find SD. We cite according this sign. Form the equation 1 and 2. That's all. Okay. So we go one more last example and then we finish this chapter. Go. I will get the question on the exercise 29H. Come here. Exercise 29H.1, page 736. See the question. Question 2. Okay. Question 2. I will explain question 2A and then the rest of the same idea. So question 2A. Question 2A on the page 736. They say if Z has standard normal distribution by using technology, but you don't need use technology. You use the way I give to you, okay? By see from the table. So if the question 2A, they say P property Z greater than or equal to 0.837. Want to find this? So before when you do the question, the C-score they give you like a 2 digits, right? Now they give you 3, so you find by approximate again. Like before the previous example in the example 12, what you see on the top, P said say if less than or greater than whatever, less than 1.5. You see, we have only 1 decimal point here, right? But now become 3 decimal points. So we can do by find the approximate or the average. Go back to see the table the same way. You go to see the table, page 735. Page 735, okay? Page 75, you see the C-score. I draw this one. I draw this one now. go to see the C score. Is it equal to this one? 0.8 here. This from this a positive 0.8 should be on your right hand side, right? So you see C score, this one is that, right? And this is 0.0, and this one 0.00, 0.01, and so on. You lead down up to 0.8, right? And then go up to 0.03. You lead 0.83. So 0.83, you will find the number here. Go your table, okay, 0.83 is 0.7967. 7967. But because we need to lead up to 0.837, so you go next 0. Just say the next one gonna be 0.04, correct? From here you lead down and lead 0.84 here. You will make what the number next one? 0.9. Sorry, 0.7995. This one 0.7995. Okay, because 0.837 is dot between here, correct? Because when you lead this one 0.8, like this one 0. From here you have 0.83 and this one 0.84. If you lead the next 3 digit, this one gonna be 0.8, lead like a 3 digit like this one. So this one like a 0.830, correct? And this one gonna be 0.840, correct? If you lead us according to 3 digits. So this one is dot between, right? 0.8, sorry, 0.837 will drop between this one. So how to do? Then you get this one, the probability area you lead, sum it up and divide it by 2. So we sum this one, what we have? 0.7967 plus 0.7995. 0.7967, 0.7995. Okay, is equal to 1.5962. Then divided by 2. We have 0.7981. Okay, so we get the answer for this, but not the final because this one's greater than, right? So we plot graph. Plot graph, take a look at graph. Okay. This one, like this one, if you go back to this one is 0 here, right? And 0.79 should be somewhere here, right? I mean, the C score. We lead up to C score is what? Not this one. 0.87. Right? 0.87. This one, we draw the lead, the straight line. Because we always lead from the left end area, right? So, So this one going to be 0.837. Because we lead this the answer from the left end area. We lead because this one greater than. So the for the shaded for this answer 0.83. 0.837 going to be from the left end here. Draw up to here. That's a C score, right? This is a C score. This one equal to the area of equal to this one 0.7981. But the question want to find greater than this one. So the answer should be here, right? The answer they want here. This one, the green one here. So because the property, the whole area of 1 unit or 100%. So in this case, you have to get 1 minus this one, 1 minus this one equal to the green area, 0.7981. So you use minus 1, you're gonna left equal to 0.2019. So this is the final answer. So this area is a 0.2019, which is C score greater than 0.837. So that when you put, you need to put graph and show and line like what I did here. Okay, so this the case when C score not in the 2 decimal point, they have more than 2 digits of the decimal point. So you can do by this way, approximate, sum it up and divide it by 2 and put graph. If less than, you just answer, but greater than, you have to find out, get the 1 minus. Okay, 1 minus the property area. Okay, I think this one, when we finish the statistic, okay? So please, everyone take a look at this one. And if you have question, you can ask me on Monday in the classroom and try to do the question I assign. And you go back to see in GC, I tell you all what question you have to do. And in the class, we already assigned from last week. And this is a new one. So try to practice it. It's gonna be in your final exam. Okay, okay. So, okay, I think that's all. Thank you. See you Monday. Bye-bye.